Hey students, welcome back. This is your last video from chapter 6 or unit 6. We're going to talk about bond enthalpies. If you're going to read more about this, it's right here, 1010. We also want to go to page 432, 81, and 83. We're kind of going to use this, but we're not really going to use this. And it looks like looks like Miss Griffith made a poor choice on vocab there. All right. I think I just copied and pasted and kind of forgot. Okay, so here we go. Let's jump into bond enthalpies. This is truly vocab that we need. All right, bond enthalpies. We're talking about the amount of energy in bonds. Now, real quickly, how much to form bonds, right, is what we're talking about, how much energy it takes to form bonds. All right. Now, bond energy is we're talking about that, the Coulomb's law coming together, that attraction, and then holding it together. So we're talking about that energy within the bond. So how much energy is held in the bond? All right. Not into bond. Boop. In bond. Okay? So now, here we go. Here's the thing I really want to really reiterate there. All right? So, to do this one, to do bond enthalpies and figure out bond energies, we use the phrase bonds broken minus bonds formed. In this case, you did not use this, which makes it a little confusing because it's like, when do I use each of these? But we're going to use bonds broken minus bonds formed because it takes energy to break bonds, and then when bonds are formed, they release energy, thus the negative part, right? So don't be confused. We're going to use this right here, bonds broken minus bonds formed. Now, on the AP exam, how they do this is they just give you a little table off to the side and say, hey, find the bond enthalpy for this reaction. And they have that little table. For us, we're going to refer to page 422, and there's a whole bunch of average bond enthalpies or bound energies, which is the amount of energy it takes to break that bond. So, again, what I like to do is I like to look. So, at some point, we could have also learned this during our bonding unit way back in the fall. We kind of have to draw our structures so we know what we're looking for. So if we have CH4, when we draw that one, Lewis structures, right, we get this, all right? Then we have two H2Os, so each one looks like this. We got our lone pairs, but there are two of those. We need to remember that too. Then we have four H2s, so each H looks like this. Then we have we have CO2, which looks like this. All right, and then lone pairs on each end there. So we have some double bonds. So we're talking about, remember, we're taking bonds broken minus bonds formed. So all the bonds that we have broken, we have 4 CH bonds that need to be broken. We have 4 OH bonds that need to be broken. Everybody see why 4? There are 2 per water molecule. Then we're going to subtract 4 HH single bonds, and then we have 2 CO double bonds. That shouldn't be a bracket, that should just be a parentheses. All right, and then we just look at that handy-dandy chart and find each of these. So we've got 4 times CH, so we look for CH. There it is, 414. Plus, we've got 4 times OH, 464. Minus, we have 4 HHs, 436. And this next one's going to be a little bit stronger, right? Because it's a double bond. Remember, double bonds are a little bit stronger. And we have 2 at 611. All right. Awesome. So let's kind of do our math there. We got 4. Let's clear that. 4 times 414. We got 1656 plus 4 times 464. We get 1856 minus, we got 4 times 436, 1744, and we've got 2 times 611, which I should be able to do that in my head, but whew, Miss Griffith, late in the day. All right, so we're going to add the 1222 plus 1744. All right, and here we have 2966. We can put it in brackets if you want. So 1656 plus 1856, 3512. And so then we're just going to subtract 2966, and we should get a delta H of a positive 546, and that's kilojoules. And there's our answer. I hope you have a great day, and I'll see you next time.